Hello there, my nerdy Nog dogs. Thanks for tuning in. This is Mrs. Nagdev, and we are talking about chapter 4 in our science text. Last week, we talked about weathering. What is weathering, you ask? Well, you should remember, it was your assignment for the previous week. Weathering is the breaking down of rocks into smaller pieces and into smaller sediment. This week, we're talking about erosion, but they actually kind of do go together. So let's talk a little bit more about the breaking down of the rocks and weathering. Physical weathering, we know, can happen from tree roots or from possibly water getting between rocks and then freezing and breaking the rock further. So I have someone who knows a lot about this stuff, and I know you like to talk to him just as much as I do. I don't get to see him that often anymore. So how about we give a big shout out to my friend, Doug. Hey, Doug.
It's Doug. You're looking at Mount Everest, the tallest mountain in the world. Mount Everest and the surrounding Himalaya mountains are so tall that astronauts can see their snow-capped peaks all the way from space. Part of what makes mountains so impressive is that they're solid rock all the way through. Like, look, this isn't a mound of individual rocks piled up really high. This mountain is one single solid rock. Mountains are like walls of vertical rock going straight up into the sky. But will these mountains always be there? Do mountains last forever? You might think, well, yeah, why not? But let me tell you a story. A story about not a natural mountain, but a mountain made by people. This, a pyramid, like the kind built by the ancient Egyptians. The Egyptians lived right here, but our story actually takes place on the other side of the world, here, in the jungles of Central America. The people over here made a type of pyramid too, a people called the ancient Mayans. This is the Mayans' most well-known pyramid. It's a great temple called Kukulkan, about 100 feet tall. Now, pyramids, unlike mountains, are not one solid piece of rock. Instead, they're built up, layer by layer, brick by brick, using stone bricks that have been chiseled by hand. About 1,000 years ago, the Mayan people abandoned the use of their pyramids. They actually left them, and they went to live in other places. Most of their pyramids became long forgotten. In fact, hundreds of years later, people didn't know many of the pyramids were even there anymore. They were lost in the jungle. What happened to the pyramids? How could something that big go missing? About 100 years ago, local residents were traveling through the jungle and noticed this. Do you see it? It's a giant hill covered in trees. There aren't many hills around here, so that's kind of weird. The residents who noticed got interested, so they went closer to check it out. When they got to the base of the hill, this is what they saw. They noticed that weirdly, the trees had been growing in a pile of rocks. So they started removing the trees, and when they did, here is what they saw. This. Look at that. It's the steps of a pyramid. Once they finished removing all the trees, this is what was revealed. It was one of the ancient Mayan pyramids. It's so cool. So what happened? Well, here's a close-up of one of the trees before they removed it. What do you think?
Oh, sorry, I kind of cut Doug off. So I have a question for you. What do you think happened there? Kind of interesting, right? That is a sign of physical weathering. And very likely a seed somehow got nuzzled. Remember, they talked about the little brickwork, possibly even just nuzzled between one of the little bricks and found some water. And next thing you know, started to grow roots. Well, believe it or not, plant life and rooting is strong enough to break up cement or break up the brickwork. Pretty cool, right? So I want to show you another little bit. Now we're going to talk about what happens when that rock or material breaks down a little bit. So amazingly, the rock and whatnot can grow, or I'm sorry, the roots can grow within the rock. And here Doug is going to mention just a little bit, so we have a little bit more to hear from him. And then I have some other fun stuff to show you. So Bring it on, Doug. Tell us.
The pyramid's bricks used to look nice and straight, but now they're crooked and some have crumbled. What happened? It seems like the trees were breaking the bricks. Is that really possible for plants or trees to break something as strong as rock? That sounds crazy. Roots aren't that tough, are they? But let me show you something. Here's a whole bunch of solid rock. It's what used to be a lava flow. But the lava cooled, and so now it's solid rock, and it's tough. You would think that it would be here forever, but if you look closely, as it cooled, it left some little cracks. Those are its weak spots. Seeds can land in the cracks. And when those seeds get rained on, they grow. Let's look more closely. Imagine a seed that's fallen in the crack of a rock. Now let's imagine the seed grows a little root like that. And the root will grow, and it'll grow, and grow, until it fills up the crack. Notice that the root didn't just get longer, it got wider too. Now the root doesn't just stop there, it keeps growing. As the root grows bigger, it pushes outwards like this, until eventually, crack, it breaks the rock, making...
Okay, so it breaks the rock, right? Same would go for if water were to seep in between the two little spaces. Next thing you know, we should know this, that water, when frozen, expands. So that could also break rock. Rock can also erode with wind and continuous water. So this is kind of how weathering and erosion go together, right? The bigger rocks get broken apart by weathering, and then they slowly erode away and the sediments get taken to a new location. So what we're really focusing on this week is more of the erosion. Erosion, the sediments traveling to new locations. So in chapter 4, lesson 2, you're learning about erosion and deposition, and that is the placement of the materials in a new location. I do have a little, it's kind of a time lapse. It's really cool to picture and check out, so I want to show you that as well. So keep watching for your viewing pleasure, my friends. Here is a time lapse. Here we go, and I want you to focus in on where my mouse is moving this little bridge right there. Slowly gets taken up as the waves come up and left at it. And there's the simulation of So what we want to keep in mind is that landforms change over time and everything eventually erodes, and especially with wind, water, ice, they erode at a faster pace. So the last little point I want to make before I let you go, and you can read in your text about it, is a major happening in our history, and it was called the Dust Bowl. And we have learned so much since this time. Most of our farming practices really came out of this era, and we developed and engineered things and put things into place so that we made sure that this would never happen again. You have a little bit of the reading of it in your text, but I want you to see some video because it does have some really amazing primary sources, which are real pictures showing you the history of the people who lived during the Dust Bowl. And the really amazing thing is people in California would say that they would see the dust residue from the big storms that would take place in the Midwest. And the Dust Bowl and these dust storms that would happen were several hundreds feet up in the air of just dust and dust clouds. So this week, what I want you to do is think like an engineer. And on your output page, I have a little challenge for you. Think big, think outside the box. I want you thinking about what you would put into place to solve this problem. And then again, we can talk at a later date about what sort of farming practices they did put into place to limit the erosion. Okay, so here's another quick snippet. Let's see. Okay, and here's a little bit about the Dust Bowl. Started in the Midwest.
The territory even became known as the Great American Desert because the lack of trees and water made the region relatively unattractive for settlement. However, in the decades following the Civil War, farmers began to settle the region and cultivate the fields under the long-held but mistaken belief that rain will follow the plow. In the first 3 decades of the 1900s, there were significant and continuous advances in farming technology, including better tractors, mechanized plowing, combines, and more. From 1900 to 1920, the amount of farmland in the Plains region doubled, and from 1925 to 1930, the amount of cultivated land tripled. However, farmers of the era used practices which deprived the soil of its nutrients and increased the possibility of erosion. The heavy plowing had eliminated the natural grasses of the prairie that held the soil in place and maintained moisture. Then, in 1930, a severe drought struck the Great Plains region, which lasted nearly the entire decade. The regions affected most by this drought were the panhandles of Texas and Oklahoma, western Kansas, and a large portion of Colorado and New Mexico. The more than 1 million acres that was affected became collectively known as the Dust Bowl. As the drought grew worse, the topsoil turned to dust and blew away. The blowing dust generated enormous dust storms that reached as far east as Washington, D.C. The dust storms became known as black blizzards. During the decade of the 1930s, the Dust Bowl region received anywhere from 15 to 25% less precipitation than normal. For a region that only sees about 20 inches of rain a year, this means that some areas were receiving as little as 15 inches of rain in 1 year. In some
Okay, so I'm going to stop it there. And what I want to bring up is that we've learned so much from this time, right? The greatest problem, if you heard in that video, was that farmers were planting over so much of the land and pulling up the natural prairie grass. Well, what do you think that prairie grass does? It helped maintain the topsoil. It helped soak in the moisture. And so when they dug up all that prairie grass and planted their farmlands, it left for major erosion by wind. As the wind came up, it would whip up the sand and create these walls of dust. So everyone living in that area was constantly covered in dust. They couldn't actually grow new things. And again, it was perpetuated by the lack of rainfall. So a major turning point in our knowledge of farming, which you know is a big deal in the state of California. So there's a little bit of that in our reading this week. I asked you an engineering question on your science output page. I will have all the videos that I showed today up on Teams, and I would like you to check them out. And definitely after you have watched this video and read your materials, you can complete that output page. I want you to complete or share that page with me. You need to use your Microsoft 365, open a Word file, either copy down what I had shared with you or rewrite the questions. Please share that with me. I expect to have it by Friday. Okay, so that's kind of a preview of what we're talking about in science. We have another science meeting on Wednesday. I will see you there. And that's it, nerdy Nog Dogs. Keep up all the hard work. Mwah.